let's go. Today
Right.
is fun stuff. It's fun day today. And I hope that you have been paying attention to pointers and become reasonably comfortable with them, because today is pointer day, most definitely. And of course, Bernard, this is the answer to your question. Tell you about user spaces.
Okay.
So that's what we're going to do. And I've tacked onto the back of that, we're going to discuss user indexes, because that is what we're going to use in the new trigger program that we're busy with. So let's have a look at what is a user space. Now, it's a very difficult thing to describe. It's a space. I'm sure you got that. It is and has a library and name and an object type user space. That's it. So you create a user space, give it a name in a library, and it has an object type user space. That's it. It starts there at P, and it ends to a length of up to 16 megabyte. Now, what is very nice about user spaces is they are dynamic. They will stretch and shrink depending on what you are using, and you don't have to worry about it. That's all done internally. They are also very quick because they are memory resident most of the time. They get forced into static storage every so often, but between the start and the end, whatever you put in there is entirely up to you. How you construct it and what you put in there and what you keep in there is entirely up to you. If the library is QTemp, which 90% of mine are, 99% of mine are, then the user space is persistent for the job, because the QTemp library is the job library, is a job library. If you want the user space to be permanent, you then put it in another library other than QTemp. However, you've got to be very, very, very careful if you want to do that, because there are no locks, controls, or system management around a user space like you find on files. So 3 jobs can access the same permanent user space at the same time, and you have no idea what's happening in there because the changes come from every direction possible. So if you're going to use a persistent user space, you must really know what you want to do with it and how you want to manage it. Most of them, as I say, are job related. They're all built in QTemp. If you log on to AO and drill down about 6 levels, whatever, to anywhere, and then you have a look at QTemp and see what's in there, you'll see there are a huge number of user spaces and user indexes in there. I use them a lot because they are very, very fast. Much faster than anything, data areas, data queues, files, even files. They're faster than files. But you decide what you put on the inside. The other thing is they are not run or managed by the database management system. They are managed purely and simply by whatever you do with them. So there's no read, there's no write, there's no update. They are managed through system-provided APIs. Now, let's get on with this. What are these APIs that a user space that allows you to work with a user space? Obviously, the first one is an API that allows you to create a user space. The next one allows you to change the user space attributes. The third one allows you to retrieve a pointer to the user space. Now, this is the trick with user spaces. You can use that API to retrieve that pointer, the starts at P pointer. So you might know the name of the user space, but the name of the user space doesn't help you to manipulate or work with the data in the user space. You need the pointer to the user space. And this retrieve pointer to user space, you give it the name of the user space and it will return the pointer to the first byte in the user space. From there, you can do whatever you like with it. There are delete user space, which is blue because I don't use it very much, if at all. These three, change user space and retrieve user space, those three are more for use by CL and other languages that don't efficiently work with pointers. Then, of course, you get retrieve user space attributes. So I'm going to now, if this works, I hope it does work. I want to look at the APIs. I have a habit, I've always had a habit, and I'll show you, of not using the system APIs raw. Because there's a lot, sometimes there are a lot of parameters and complexities which I'm not interested in getting involved in, because there's certain types of user space or certain styles of user space or certain things that I want to make easy to work with. I mean, you can see here, this has got 12 parameters. Now, you don't want to code all of this every time you want to use a user space. So I always wrap my user space, my APIs, into a module and bind it into a service program, so that that procedure is mine, and it performs a particular function within, or uses the user space in a certain way. I have a create user space. Now let's just have a look at what these parameters are. I'm going to point out this one here particularly, which is very interesting. 7.5, this is a new parameter that was being added to the create user space. Prior to 7.5, it wasn't there. You had to use another API to set the automatic extendability. So I have not updated my APIs because I have 7.2, but it still works perfectly well, even at 7.5, I'm sure. Right, let's have a look at these parameters and see what they do. Qualified user space name. That's the first parameter. First 10 characters is the name of the user space, and the second 10 characters contain the name of the library. Note that user spaces created in QTemp are not forced to permanent storage, and they are deleted when those libraries are cleared at sign-off and system IPL respectively. So a user space created in QTemp is persistent only for the job that's running. Right, extended attribute. Don't use it, but you can. The extended attribute, for example, an object of file has an extended attribute of PF, LF, etc. You can give it any name you want as extended attribute. I've never used it. I don't bother. Initial size. What do you want the initial size of the user space to be? Notice it can be from 1 byte to 16 meg. I'll show you the code that does this, so you can see exactly how I manage this. The initial value. The book says you will achieve the best performance if you set the initial value to x00, binary zeros. That fills the initial space with binary zeros, cleans it out, so you get the best performance. I honestly don't know whether that's true or not. I never tried it. Here, you give it a public authority, i.e. what authority can be used for this. You have a text description. Then this parameter is a replace parameter. Do you want to replace an existing user space? Or yes, do not replace it, or yes, replace it. Now, if you say no, it's going to crash. It's going to say to you, this thing already exists. If you say yes, it will replace it and erase what's there and give you a new one. I don't know what I use. We'll have to have a look at that. Then you get this error code. I'll show you this in the code. This IO character, this is an input-output parameter that is in all system APIs. It gives you a structure which returns error information. And you can see it here. I'll show it to you when we look at the code itself. If this parameter is omitted, diagnostic and escape messages are issued to the application exactly the same as the system. Domain, I always use the default. The rule of thumb here is unless you know what you're doing, use the defaults. Transfer size request. The number of pages to be transferred between the main storage and auxiliary storage. This is only a request, as the machine may use the value of its own choice. So the default is 0. It says the machine must decide on its own transfer size for the user space, and I have never bothered to worry about that one. I actually don't. There may be some little bit of differences, but I don't know. Optimum space alignment, again, use a default, allows the machine to choose optimal alignment for the user space. Choosing optimal alignment is highly recommended, etc. One is the default, choose the optimal alignment. So we let the machine get on and do it. I have found that the machine does a better job in 99% of the cases than we can ever do. If you're using the optimum space alignment, the user space has a maximum of 16 meg, minus 512 bytes. That's all. Then automatic extendability. Whether or not the user space is automatically extended by the system when the end of space is encountered. 0 is the default, which is not extendable. 1 is that the user space is automatically extendable. Depending on what you want to use it for, but I would recommend you use extendable user spaces as a matter of default, because you don't then have to worry about making space available for these things if you want to use more or less or so on and so forth. So those are the parameters which allow you to define and create a user space. Now I'm going to find user space, UIX user space. Come on. Right, here we are. This is a module that contains, the APIs for using the user spaces. Now, I will provide this to you with the greatest of pleasure. Because I can't see my own face, I'm going to turn it off. And I have these APIs, A, B, C, D, E, and F. create user space, delete user space, retrieve the pointer to the user space, retrieve user space information, and then two others just to quickly create a work user space and a work user space 2 in QTemp. Those are just quick APIs to create. But the 4 that I use here mostly are A, B, C, and A, C, and D. Let's have a look at A. Now you see, there were 12 parameters in the create user space API. I simply have reduced it to 2. I have one user space for the name and one parameter for the library, but it's a no pass option, which means I don't have to pass that parameter if I don't want to. So when I want to create a user space, I can call this API and just pass a name, and it will create the API in QTemp automatically. Makes life simpler. I will make these available. I will make them available as source. I'm going to ask definitely if you wouldn't mind compiling them and making them into actual service programs. It's just to give you practice. I will provide the source. If the parameters are greater than 1 and the user library is not equal to blank, use whatever library was provided. That's the option to create one in another library. Seldom used. User space name and library, we add the two together, and then we also have a user space library name, which we put the other way around. And the reason for that is we use a check object command to see whether that object already exists. This is the way I've put the command into your error handler. You've seen it there. It's in error handler 03. And you can run CL commands using this command from within an RPG program, and it will return. Now this here is C. This actually retrieves the pointer to the user space. So if it exists already, I will return the pointer to the user space. Retrieve the pointer to the user space, and I will return the pointer. If it doesn't exist already, I will create the user space, and you'll notice all these parameters are filled in already. My default size is 3000 bytes. That's the number I chose about 15, 20 years ago, and I haven't changed it. It's called user space, very original. And the other parameters are just, there's the initialization parameter and so on. So that creates it. That sets the extendable attribute so that it becomes an extendable, and then I return using the C again. I return using the pointer, sending the pointer back. So after creating a user space, which actually is a function because it's returning a pointer, I have in my program, I have the pointer to that user space. Okay, so that is the code. It's simple code, but it eliminates all these parameters and calls and this sort of thing. These are all the definitions for the procedures which are wrapped up in the service program, and they don't clutter my application code. Okay, so that's the create of the user space. If it's there, I return the pointer. If it's not there, I create it, set it as expandable, and return the pointer. The delete is quite simple. I delete the user space. If you call this one, you give it name and library, optional library, and it will delete the user space. Retrieve pointers to the user space. This one you can use at any time, anywhere in the job. I don't have to, I can call this because it's an exported procedure. It is a function because it's returning a pointer. And I can use this procedure out of the service program to get me a pointer to the user space that I know the name of. So very simple, but it eliminates the code in your program and simply reduces the request to a single line. Then retrieve user space info. This is to retrieve the information for the user space. I very seldom use this, if ever, because I don't need to know. I know the user space is a big empty space, and it can get as big as 16 meg. By the way, I have never managed to break that boundary. So it's pretty much indestructible. And then these are the two extra ones that create, you have no parameters. It returns a pointer, and it's work US QTemp, and the other one is work US2 QTemp. And these are just creating exactly the same way. Okay, now at this point, are there any questions? Because you can see that is using all 4 of these APIs. Oh dear, I've clicked the button wrong again. Are there any questions?
I have a question.
Yes.
There's a command to see the content of the user space. Or I need to use a program to see the content of the user space.
No, there is no command to see the contents of a user space. They did write one years ago. You remember there was a tools library. I don't know whether you remember that. QUser tools was,
yeah.
And they wrote something in there that you could look at a user space. But the problem with that is user spaces are so varied and so different that really you can't format it. It's really a free-for-all space, and it's custom built for what you want to do for it at the time. So the only way you can look at a user space is to retrieve the user space pointer, set up a data structure, and that will give you, and base that data structure on the pointer. I'm going to, if I can find it and get it to work, I've got some examples of this code. Just bear with me, I've just got to find it. You know, I had it here. I think somebody's stolen it. Marinus, how's the quality of this sound?
It's perfect, Tom.
Okay, good. Okay. I was in the wrong place altogether, so that was probably the reason for it. USB source files there. Right. I've got a couple of examples of programs. Here's one. Now, please, this is a program that is an example. It won't compile because it's missing a large amount of some things. But it is an example of how one would use a user space. And I need you to look at this very carefully and understand exactly what it is. You would create a user space definition in your data definitions of your program. And typically that is, well, that together with that. I've gone and messed it up. Let me just enlarge this because I do know. Why is this not working? Dear. All right. You declare a pointer. You need a pointer. And then you need something, and in this case, it's a data structure based on that user pointer. And in that data structure, there is something. Now, this is a particular, very common style of storing entries into a data structure of a fixed length. The first two fields in your data structure are number of entries and entry length. Then you have another set of entries, an user space entry pointer, and the entry itself. Now, what I've chosen here is I've chosen 10 because when we come to the trigger and we want to put a program name into the user space or the user index, we are going to use one, but this is 10 characters is the size of the entry, and it's based on the entry pointer. If I'm not making sense, please stop me. This entry can be anything. It can be a data structure. It can be a single field like this. It can be a whole slew of fields, all based on this pointer, okay? Usually a data structure or a single entry. Now, notice this is a new activation group. I do that all the time because if you want to use this to test and debug, that's a good way of doing it. And there's my start commitment control that goes along with the new activation group. Right, the first thing I do, user space pointer is equal to the create user space, and I've given it user space 1. That's the name of the user space. That's the API. It's just to create user space and the name and the library, which I'm not passing because I wanted to create it into Qtemp. Now, this is the trick. I want to get at the first entry in the user space. So I create the user entry pointer, that one there, equal to USP plus 8. Y8. Any offers? Stunned silence, I guess.
Yeah. Y8. Joel.
You catch it every time, Joel. Eh? Right. Obviously, no takers. The 8 comes from the fact that this is the user space here. It's based on the user space pointer, which is the beginning of the user space. And the two first fields in the user space are number of entries, 4 bytes. It's a binary 10, which is 4 bytes. And the entry length is a binary 10, which is 4 bytes. So to step over those and to get the entry to be the first entry just after that, I need to set the entry pointer, this entry pointer, to the use space plus 8. 4, 8. So this entry is now pointing to the 10 characters just following the entry length. Now, I'm going to stop and let you think about that for a moment, because you need to get the feel for this completely. Otherwise, you're never going to make them work for you. Eventually, after a while, it's so second nature to me that I really don't have to think about it. But it's a little bit of a mental gymnastics to try and understand that you've reserved the first 8 bytes in the user space for the number of entries and the entry length. I start with 0 and I know the entry length is 10, so that's fine, no problem. The entry pointer is the pointer to that because this entry is based on this pointer. So entry pointer is the US pointer plus 8. Now, I'm not going to carry on until I get the go-ahead. Is this clear?
The user space, it comes automatically with that 8-byte, those two parameters are coming automatically, or we are putting.
You created them in your user space data structure there.
Yes, that's why it's us that we put.
You put that in there because you want to control how many 10-character entries there are in your user space. Remember, 10 characters, 16 meg, you can put an enormous number of entries in that user space. Okay, I've got another example which is completely different, and we'll agonize over that one. So the 8 bytes, yes, you create. The only thing that this gives you is the pointer to the space. You base a data structure on that pointer, and the rest is up to you. You can construct it any way you like. And let us have a look at this program, which actually loads entries into the user space. Do while indicator not equal off. I don't know what that is, but anyway, I put that in to make a loop. Something, I don't know what that would be. User entry equals something. The something must be a 10-character field, because you're putting a 10-character field into the US entry, the user space entry. Then you are adding 1 to the number of entries, and you are adding 10 to the entry pointer. So I'm moving this pointer down 10 characters, so it's past the previous entry I've just added. I could also do this, plus equal if I wasn't sure what the entry length was, I could do that. Plus equal the entry length, because the entry length I've initialized to be 10. So all my entries are 10. So I put something into the US entry, the user space entry, which immediately follows these two. I then update the number of entries, use the entry length to move the pointer down to point at the next entry. So this pointer moves down by 10 characters, so it points at the next entry. And then I go and fetch the next one, go around and move something into the user entry. And that means I've put 2 entries in, and this will go around until the fetch next gives me an indicator that's not off. And then it'll stop. Now, you asked about user spaces, Bernard. These user spaces are very, very, very fast. I use them for arrays. I use them for storing stuff for other programs. Remember, I can put stuff into a user space. in the second program in a job, I can then make that available to any program, 5 calls down the stack. All that program has to know is the name of the user space. It can then go and get the pointer. As long as it knows the structure of the user space, it can get the pointer and it can have access to the user space that was created up at the top of the call stack. It's fast and so flexible. You can use it for anything. It's only limited, unfortunately, by your imagination. And you need to get a little more comfortable with it so that you can begin using it for the purposes you want to use it for. Remember, my requirements are very different from your requirements because I'm writing a tool. It has different behaviors. You writing an ERP or you maintaining an ERP, which is a completely different animal. So you would use this sort of thing differently. Do you use dimensions, arrays, or anything like that in your apps? I'm sure you do.
I'm not sure. Dimensional arrays?
Yeah, arrays.
Arrays all over the place. Yeah, a lot. I know that Diane does.
You see, this is a replacement for arrays. Very much so. They are much, much faster than an array.
Yeah, but the beauty is that they are shareable. You can share between programs because very often the first program is doing a bunch of arrays and then the second one cannot use them. So
yeah, exactly. Here, you can either pass the pointer as a parameter. If it's just the next program, you pass the pointer as a parameter. If you don't know what program is going to use it, now there's an example. If you're doing transaction processing, okay, and you've got an input transaction file which has all sorts of different transactions, you may not know which program is going to be using this user space. You prepare it, but you don't know which program is going to be using it because that depends entirely on the transaction type of the transaction. So you would then simply let the program retrieve the pointer and it has access to the pointer space. That means you don't have to pass parameters from program A to program B to program C to program D to program E. You don't have to pass parameters. Any program that wants to use it just has to pick up the pointer. As long as it knows the name of the user space, it can pick up the pointer and it can work with it. So this is one example. I use this a lot. I store things in these and check them again. Remember the other thing that is actually interesting about this. If you set this pointer, let me put this, let's assume now that's 200 entries. If I set this US entry pointer using this value so that it is set, sorry, I've left something out there, based. Okay, I've based that US long, user space long entry on I based it on the same US entry pointer. Do you see that? So actually, this is 2,000 bytes overlaying however many stuff I've got in there. Now, if I'm looking for an entry to try and find out whether there is an entry of 10 characters, name whatever, I can use this. SCAN. Let's just do A, B, C, D, E. I'm not going to worry about what it is. That and US rather long. Now that means that I can scan that user space, the first 2,000 bytes of the user space. I can scan it looking for the pattern ABCDE inside that user space. And if I find it, it would return a non-zero value, in which case I know I found it. That makes sense? Sorry, I've lost it again. What? You're quite comfortable with what I've just said to you? Because it's a data structure. I can define it any way I like. I can enter 10 character fields and I can search for them using a scan like that. I've done that often. Very fast because it's a straight alphabetic scan. You're very quiet, which worries me. Okay. I will give you this as an example. You can take it apart to your heart's content. But the whole thing is you can base anything on the user entry pointer or the user space pointer, and you can construct what's underneath that in any way you like. Now I'm going to show you another example. Let us assume that this program is going to read a record out of file 01 based on some criteria. And this, by the way, here is an expanded copybook, just so that you can see the various different elements. This is an IO server for that file. These are file 2 and file 3. And these are actually IO servers for these two files. So they look exactly the same as this, only they're not expanded. They're in copybook form. Now, let us assume this program is going to, what I've done is I've got the same structure there. I've got a USP pointer, and then I've got only a pointer, nothing else. I haven't got anything else. Notice there's no 8 bytes after that pointer. There's no data structure there. This entry pointer is a pointer, and this is a data structure. It's got entry length and the entry record. Now, what this program is going to do is it's going to, based on some input parameter or criteria, it's going to find a record out of the first file, and it's going to store that record in the data structure, in the user space rather. Then, based on what the contents of that file were, I would go to file 2 and get another record and put that in the user space. And similarly, file 3 and put that in the user space. So I'm intending to store 3 records in the user space because these three records are going to be needed by programs further down the stack. So this program is simply designed to look at the criteria and to populate the user space with 3 records chosen based on criteria that were input. So let's have a look. User space, I create the user space and I get its pointer. And immediately I make the user space entry equal to the user space because I have nothing in the front of the user space. Right. Then I use a key, file 01, and I read the record from file 01, whatever that might be. I then take the length of that record and I place it into the entry length of the entry there. And then the user entry pointer, oh, sorry. Sorry, this is wrong. I made a mistake here. And you guys are not catching me. What mistake have I made with that particular parameter? I'm reading a record using an I/O server.
The error.
I've actually messed this up completely because I was hoping to get terribly smart, but I didn't. I'm going to put this as USBNTP. Now, we're going to take this one and we're going to put it up here. So we're putting the entry length right. That's better. No, it's not. Plus equal 4. Now what I've done here is I've taken the length of the file, which I've got here. It's the size of the file record. And I've moved it into the entry length, which is there. I've then added 4 to that pointer. So the US entry pointer is moved down to now be pointing at the entry record. So that's the pointer. That's wrong. That shouldn't have a bracket there. Right. Then I set the key and I read the record directly into the user entry pointer. You with me? Anybody still not with me? I knew this was going to be fun for me. I didn't know whether it would be fun for you.
Well,
let's look at it again.
Is there a difference, Tommy, between, pointers are, they are pointing into memory, and is there a difference between a user-created user space and the user space used by your program.
No.
And
a user space is a user space. It's an empty area that you manipulate as much as you want to.
Yes, but there's already a user space created by the program.
There, yes.
So now we have two user space.
No. This one, remember what I said with the create user space. The create user space checks to see whether the user space is there. And if it is, it just returns the pointer.
Okay. Okay, I see.
Okay. So this would create it the first time. If you called this program again, it wouldn't create it because it would be there already.
Okay.
Here we set the pointer, the entry pointer, to the beginning of the user space. We could actually save ourselves some other some trouble here and some lines of code by removing that and removing that, because we don't really want that. So we make the user space entry pointer equal to the create user space pointer. We put the length of the record we're going to put in there into the beginning of that. We move the pointer down by 5, and then we read the record straight into the record entry there. Okay? Now what we've got to do is we've got to move this entry pointer down by the entry length. Because remember, the entry length is the length of file 01. Moved it down by 4, put the record in that space, and then moved it down by the entry length. So I'm now ready to nail the next record. So that would be now notice that the second record, which may be a completely different length, may contain completely different data, but it's written into the pointer. At this point, the pointer is just past the entry length of the second pointer, the second entry. And then this would go there. That's not. I coded this, but I didn't see this efficiency here. So that one is exactly the same. Put the length into the entry length, move down, find the record and read it into the user space, and then bump the user space up by the entry length. And I'm going to just simply take this. And we're going to do the same with 3, 3, 3, 3.
But Tommy, I have.
Yeah.
Why do you add 4 all the time?
I've created the user space here.
Yep.
So this entry pointer is pointing at byte 1 of the user space.
Yeah.
Now, byte 1 of the user space has got the entry length in it for the first entry.
Yeah.
So I then move the length of the record into the entry length. So this now contains the actual length of this field. It's defined as 4096.
Yep.
But it doesn't have to be. Okay. You with me? Now I have to move that pointer down by 4 to step over that entry length and position my pointer onto the entry record.
Okay.
Because I'm reading my record into the US entry pointer, which is pointing at this now because I added 4.
Okay.
And then I up the pointer by the length of the entry that I've just filled in. That is the length of this file. So it's moved all the way down to the end of that record, and it's pointing to the entry length of the next entry in the user space.
Yep. But why again adding 4 to it?
Because I put the length of file 2 into the entry length, and then I have to step over that entry length to make space for the next record that's coming in. Let me see.
Right. To me, it's because you won't override the first one. You doing it that way?
I'm moving it down the user space.
Yes, but now you add the length, so your pointer is going to be at the end of the first record.
Of that file, yes.
At the end of the pointer will be at the end of that record. So
yes.
Now you
start
over again.
I want the length at the end of the first record.
So
you see,
every record will have the entry length and the record itself. Okay, that's why, because every record's gonna have its own length.
Because there might be different lengths. This example was with a fixed entry length, right, of 10. And so you can put the number of entries and the entry length up the top. And there's only one entry length. But here, you've got 3 records going in, but they could all be different lengths. So the entry length has to be the beginning of the entry, not the beginning of the user space.
Okay. Okay.
You sure?
Yeah, I'm sure.
What about the others in the crowd? Okay. I guess you'll sort it out between yourselves later.
Yeah, but to me, what's not clear to me is that so far, with all of what we have done so far until this morning, we were dealing with user space all the time. But what's the difference today?
You were using pointers.
Yeah.
You were not using user spaces. Remember, up until now, your file, your IO servers, for example.
Yeah.
Now, let me see if I can find one quickly.
We were using pointers, but what was that space? What was that space?
Okay, I'm going back because I have to make sure this is quite clear. Where am I? I need the IO servers. Here we are. This is the IO server for prod ord. Okay. Now, here you have prod ord P, which is a pointer. You have prod ord K, which is the key, and you have record, which is based on prod ord P. So the record here in the IO server is based on that pointer, right? But this record is defined in the program that calls this I/O server. And the pointer is passed to this I/O server. You follow me?
Yeah.
So there's no user space involved here. In the calling program, let me just go back here to this. In the calling program, you would have a definition of the copybook here. You see, this is the program that calls the I/O server. You've got the action, the pointer, and the key. You have a key space, you have the length, you have a pointer, and that pointer contains the address of that record, which is defined by a data structure in this program. Not a user space. This is a record in this program.
This is the memory for the stack, the call stack.
Yes.
It's the activation group. So
it's
that's kind of the shared. That's the shared memory of the activation group.
Well, it's created by this definition here, this record.
Yes. Okay.
Data structure, external name, file 01F, qualified end data structure. That carries the structure of the record. Okay. Now the pointer,
it's not the same thing. It's not the same pointer. It's
is the address of that record. And I pass that pointer through to the I/O server. So the I/O server receives this pointer, which is the address or the pointer to the record from the calling program. It's based.
Okay. So the user space itself, it's kind of a second memory space.
The user space is a different object altogether.
Yeah. It's a different memory. It's we work on it with pointers, but it's not the same pointer as the activation group pointer. It's really its own pointer.
This is why I knew we were going to have fun today. That pointer is a pointer to the record data structure of the calling program. It's defined in the calling program here. It's defined here in the calling program. There is the data structure record, and the pointer is the address of that record. And that's passed to the I/O server.
Yeah, but my question is, can you give an example of, because what you do here, you read 3 files, and those files maybe they are not into they are not defined yet into the call stack that we have, obviously, because if we get them and we put them into our user space, why we would need to do that? Because sometime we're going to have it already into memory.
No, not necessarily. You see, here I'm using the user space pointer instead of the record pointer. So the read is putting it straight into the user space. The reason behind this, as an example, was that these 3 files, there's information in these 3 files that may be used later on in the process, right?
Mm-hmm.
Not necessarily all of each record may be used, not necessarily. Some information from file 1, some from file 2, some from file 3. But the point is, if you do this, you're putting the whole record, file 1, file 2, file 3, into the user space. Programs further down can take out of it whatever they want. You're actually reading the record into a user space instead of reading the record into the calling program. That's the difference.
Yeah, but let's let's talk. Why then into this program? Why not just chaining to the file and put that into the call stack the call stack space.
No, but remember, the call stack is not a space. It's just an entry for the program.
Yeah, I know, but it might not be the right word. But if you get to the file, it's going to put it in memories.
The calling program. You're going to be putting it into the calling program.
Yeah,
but
it's going to be somewhere.
That's not available to 6 programs down the call stack. Unless
why not? Why not?
Unless you pass the pointer down 6 levels.
Yes. Yeah, you're right. Unless you know what the pointer is.
Exactly. You do know what the pointer is, because here your pointer is equal to that. That's your pointer. So you could pass it down, but you would have to pass 3 pointers down, because you're dealing with 3 records.
Exactly. Yeah.
Doing it this way and just loading them into the user space, whoever wants them further down the call stack can just go fetch them, because they're there. How do you find the 3rd record? If a program lower down the call stack wants only the 3rd record, how does it find it? It adds file length +4 to the beginning of the user space. That takes it to the 2nd record. User entry length +4 takes it to the 3rd record. +4 gives you the 3rd record. It's that simple. You just use the entry length to step down the user space to find the record you're looking for.
Yeah, but you have to know that there was 2 files before that one.
Well, the whole point, I made the decision here that was going to be the design criteria. We're collecting 3 files, and we're going to pass that information down the stack to whoever wants to use it. So everybody down the stack, this particular user space 2, everybody will know that it contains 3 records, one from file 1, file 2, file 3, based on certain criteria that now can be used lower down the stack.
Yeah. This is by design.
It's by design. Yes, that's the whole thing. Your user space, definitely every single user space you use is by design, because they can be, you've got absolutely no, you've got no restrictions here. You've got a space that can be up to 16 megabit long, 16 meg long, and you can construct it exactly as you want it to be constructed.
How many user space can we deal with?
There's no
program
limit.
There's no limit.
There's no limit. The only thing is you can't have user spaces of the same name.
But let's say we could, for example, instead of creating an array, we could have 1 user space per array.
Exactly.
So that way the array could be used down the road.
Yep.
On the contrary, today we can't. It's cannot do that. We cannot share an array between programs.
You can't. But with a user space, this particular example here, number of entries and entry length, if the length is consistent and known, you could leave that line out. Doesn't matter. This is counting the number of entries in the array, and you just fill in the entries.
Yeah.
And you can pass this. You don't even have to pass it, because if a program down the call stack wants to use it, they just have to retrieve the pointer to it. They just have to know the name of the user space. That's all. And they can pick up the pointer and they can construct and read it as they wish.
I have a question.
Yes, Tone.
Suppose in your example you've read 3 files. And then suppose we go to the next program, and this program will read those files, the information in the user space for those files. And suppose he has to put something else, add something, he had to calculate something, and he wants to pass the information back. How do you keep track of what you're putting in the user space between all your program?
How do you keep track of it anyway? You write it in the documentation, don't you?
I'm good with documentation, but it's not.
Yes. It has to be, this whole thing has to be designed. You put 3 records into a user space, and you could fill in empty fields in those records, and then you would of course go back up the call stack, and those changes would be available to any programs up the call stack if that was the design that you needed to have. And that's the important thing. It's all, you've got an empty blank space is a user space, and you can do anything you want with it. That's really the tough part. It's totally unlimited. I usually recommend the first thing you tackle if you're tackling user spaces is arrays or occurs. You know, when you've got occurs data structures, you use those.
Yeah.
Those can fit in a user space beautifully. Because remember, a data structure has a length. You can have the data structure as an entry in the user space, and so on. So those two are the prime candidates for this, because not only is it fast to populate and to read, but it's also, as Bernard said, you can pass it down to other programs, and other programs can use it easily without hassles. But you do need to document it. Otherwise, you're going to get a little bit of chaos. Actually, maybe not a little bit, maybe a hell of a lot. Okay, I had a third example. What was this example?
I think on my side, I think that for me the best way to use user space is in the way to pass parameter between different programs instead of passing parameter. Then we are going to use a user space in the way that we have a lot of parameter.
Yes.
For example, to call a service program to bring back address or a tax or anything else, then in this case, I think it could be a good way to use a user space in this case.
Well, I'm
okay.
Yes, you're absolutely correct. Because if, for example, you have a lot of parameters that you are passing from one program to another, you can make those parameters as a data structure. Yeah. And if they are a lot, I would actually put it into a copybook, because then it can be used exactly the same, or a file description. I prefer copybooks to files because they work better. But then you simply populate that data structure in file 1 in the user space. Now that's all your parameters. Now you have 2 choices. You either pass the pointer as a single parameter, or you don't pass it at all. The receiving program should know the name of the user space and can get the pointer itself.
Yeah.
So that is a very good way of cutting down and documenting and standardizing your parameter lists.
And I have another question. Do you know if it can be possible within a CL program just to retrieve the user space information? Because we are using a lot of CL program within parameter coming from RPG program, for example, and we've got a lot of parameter. Then I'd like to know if there's a way to retrieve user space information within the CL program also.
There is a API.
This command, okay.
That is an API command, and it can be used in a CL to retrieve user space information.
Okay, fine.
I find it so much easier to do it in RPG that I'm I don't write CL anymore. I honestly don't. I find it so much easier to write RPG. And when I need a CL command, I just use the CMD API, this one which I've got somewhere here.
We are using CL in the case that we are using an external tool, for example, to send an email, and we've got, you know, a kind of a tool that we have to pass subject, title, list of address, email address, and so something like that. This is an example. Yeah.
Why can't you pass that from an RPG program? Just a question.
Within yeah, I don't know. The actual way is we are using the CL program for this any kind of.
As I say, I find that just about anything you can do in CL, you can do much better in RPG. You just need a couple of toys, which I've got here somewhere. This one is in this error handler. This is now in your error handler service program. It's a thing called command, and it's very, very simple. You pass it a command string, maximum of 4096. It's a variable length character, and it does an execute command string and length. That's all it is. This exec command, it just executes a CL command anytime. The only one you
a couple of
can't
our RPGs like that. We are using exec command within the RPG also.
Well, I've wrapped it in a little API of my own.
Okay.
And I use this all the time. The only time you can't use this is when you want values returned from the command. You know, you can't use a retrieve command here because there's nowhere to put it back to. But then when I've got retrieves that I want to do, I write them as APIs and wrap them into a service program. And I use the system APIs because every single command that you can execute in CL has an equivalent API in the system. Every single one. So you either use this or the only CL that I ever write these days is this one, which is my compiler for a service program. That's the only one I ever write CL for. I haven't written CL in years. So, yeah, you can do it.
I do have another question.
Yep.
Suppose in your example, you have your user space that reads 3 files, and those information will be could be read through the user space for every program down the road. Suppose program A call program B, call program C, and in program C, I do need something else that will be filled by program D.
Okay.
How the program D will it pass the information through the same user space? How can he knows that there's already 3 records written in the user space, and
that is what the user space was designed to do. If program D wants to add information to that user space, it can do that easily because you have the length plus 4 of each of the 3 records. As a result, you know where the empty space in that user space begins. So you can calculate that just simply by adding file length or entry length plus 4, entry length plus 4, entry length plus 4, and that will get you to the end where there's unused user space. And you can add anything in the bottom there, but it's got to be designed. That's the point.
But program D maybe doesn't know that there are already the 3 files in that one. Yeah, the meaning for the program D is there to retrieve some information and pass it to program C, but it doesn't know what program C do.
It doesn't, unless it's been designed and documented so that that particular data structure is known and its structure is known and its contents are at least defined. File 1, file 2, file 3, those are 3 records that come from 3 different files. That has to be part of the documentation of that user space. Has to be. You can't just randomly throw things in a user space and hope anybody's going to know what's going on. That's the point. And remember, this is all within one job. So you're working down the call stack and back up the call stack. So it's not as if it's random all over the place. This user space is in QTemp and it's all part of the same job stream. You're going down the call stack and back up the call stack. So those jobs should have been designed to produce a result. Okay. And turn my camera on again so you can see me. I'm not sweating yet. Have I shattered your mind?
Yes.
Oh dear. All right. The thing is, this is going to take a while. You're going to have to think this thing through. The key here is you've got a space which you can create. Its name, it's identified by a name, and you can get the pointer to that space. So all the manipulation that you do around the space is done with the pointers. You can have a data structure which you base on a pointer, so you've got a data structure which is a fixed area within the user space. But if you move the pointer, you'll move that data structure. So you've got to think of it as an empty space managed with pointers. That's the key of the whole thing. I did a third example here, but it looks like it's the same. It's the same one. Oh, this was the program that was going to be called from program 2. The program 2 populates these 3 records in the file, and program 3 was the next in the call stack. And you can see it simply says the entry pointer, retrieve the user space for that user space. That means that is now pointing at the entry, the first entry. You step past the entry length, and you add the entry length to the entry pointer, and you can step down, and you can step down. So, and then you have a process. You can process the, so that's how you would read the space, depending on what you wanted. I can't be clearer than this, because it really depends entirely on what you want to do with that space. Now, it's just as Francis said, it's a wonderful way of passing long strings of parameters from program to program without all that nonsense of coding and coding and coding and coding, strings of parameters on output and strings of parameters on input. You just populate a data structure inside a user space, and that's it. You can pass a pointer if you want to, but you don't have to. Maybe you want that those parameters used 6 programs down the stack, or in an IO server, or in another enterprise services program that may want to use that. You don't have to pass the pointer. The receiving program just needs to know the name of the user space. Now, I'm not going to hammer this because you need to think about it. I'm going to go back. Yeah.
So a program could have many user space.
Yes.
How many user space do you write in the do you use in the program?
Okay, let me what am I doing? Let me see if I can find something. Oh yes, this is what I want. I want here. Right. I'm just looking here, but I'm taking this. I'm just going to bring this out here for you. Right, I'm going to just go work into the environments, maybe train, normal, we'll go down. Rod, board. Okay, I've drilled down a couple. Now I'm going to, okay, no, it's not right. Escape. Escape. Trying to, let's just go here. Work active job. We'll go here. What is this? This is TAO4. So work PJPDM, work object PDM QTemp. Now, if I do this, I will be looking at QTemp for this job. And you can see I have got rather a lot of user spaces. I have 4 user indexes, and I have quite a large number of user spaces that I store a lot of information. These are storing different records. See, they're named for the file, and they store a record from that file. So as I drill down, I'm storing these records so that I can go and fetch the information whenever I need it, wherever I need it. So this is the LDA user space, which holds the LDA, so I can pass the whole LDA down. So yes, you can have as many user spaces as you need, no problem. Does that answer the question?
Yeah. Do you have a naming? Do you have a naming convention?
No, I don't have a naming convention for user spaces. I suppose I should. I think it's probably a good idea, but the use of user spaces is so versatile, it's so diverse that coming up with some convention is pretty much difficult. You see, the name, the type is user space. So if you look at the object, you will see it's a user space. So you don't have to say it's a user space in the name, because there is the type code and it is a user space, and you can see that. So I don't use a convention, but I would imagine it might be a good idea to come up with some sort of a convention, because it might help depending on what you're using it for.
So if we want to use a user space to pass parameter between program, we could name this user space the name of the program we're passing information to.
You could.
Okay.
It can have the same name. I think the important thing is it's seeing there more than one of you on the team. You need to make sure that you all know what the conventions are that you are working with, so that you can recognize the type of user space you're dealing with. I know it's quite difficult. Do you have a regular meeting to discuss standards and naming conventions?
Nope.
We used to.
One of my previous companies, I nearly caused the whole programming department to walk out and resign because I had a meeting to discuss standards for naming programs and conventions and files and everything else. But boy, it turned into a real bun fight.
Tommy?
Yes?
Does it mean that in the case of we can use a user space to manage error message within a user space and bring back to the original program and using the user space to retrieve the message coming from instead of error handling?
Yes. You can use a user space for anything your heart desires.
Then we can feed a user space with a specific error message with description, for example.
Yes.
And reading the user space to retrieve the error message.
Yes.
Okay. Good idea.
To be honest with you, I will say yes to anything you want to do with the user space because you can. It's an empty space. You've got a pointer at the beginning, and you can only go to 16 megabytes. That's the limit. In between those two, you can do just about anything you want. You just have to be careful that you know what you're doing and that your programs know what you're doing. Remember, this user space, if you create them in QTemp, which is my recommendation, then they are job persistent. They persist for the job. Once the job ends, the user spaces are gone. Okay. If you want a persistent or permanent user space, then you are going to have to think a lot more carefully about what you're doing there, because it can be accessed by any job currently running in the system, and there's no control, there's no locks, there's no way of user B being told that user A is busy with it. It doesn't happen. As a result, you've got to
we are using that area a lot of time to manage information. There is a static, that area is keeping the same information. And this is this is not a user space, but it's we are using that area also.
Yeah, well, that you can use a user space, although you might want to use a user index for that. We'll get to that later. The one thing that I used a persistent user space for was different users would work on the system during the day, and they wanted to produce reports, but we didn't want reports to be printed regardless any time of the day that they wanted them. So reports were scheduled for the night runs. So what happened was we had a user space where the application program, when a user says, I want to print a report for this, it would write an entry into the user space to say, this is a report that needs to be done, and so on and so forth. At the end of the day, in the evening, they would run the batch print program, which would then read the user space and print all the reports out of it. That was one way we used a permanent user space. So there are many different ways.
Instead of using a file.
Yes. Because the files, there are overheads to files. You could use a file. There's no reason why not. And you might want to use a user index, which we're not going to get through because this user space has taken a bit longer than I thought it was going to. But the user space is an exceptionally powerful tool. It's wonderful once you get the hang of it. You can do all sorts of marvelous things with it, and it's fast. It's quick, it's easy. It just takes a little bit of getting used to. The thing is, I use it so much that I don't see the difficulties in it. That's half my problem. It's second nature to me. I've been using pointers for so long that I don't even have to think about it. Now, I'm not even going to get onto user indexes today. I can see that because user indexes are,
Tommy, can I make a suggestion?
What that?
Due to the immense power that user spaces have, is to perhaps for the team to actually do some homework. You've already identified arrays. And the sharing of information between jobs in a job stream.
Yeah.
And to construct something simple as a team to actually implement it at a very basic level, because the moment you start using it,
yes,
the world opens up in terms of what can possibly be done and how it can simplify a lot of things where they have to do a lot of footwork at the moment.
No, I definitely agree with that. The other thing is that once you actually write code that uses the user spaces, you can debug it. And you can actually see what happens when you move pointers in a user space. You can actually move a pointer and then go and look at the field and see that the field has changed. So you can actually debug your way through it and understand what is actually happening there. It's a very good way of getting a handle on it. So maybe you should cook up an example, maybe one of your arrays or whatever it is, just a little example that you can run and debug. Or passing a parameter set from one to another, you can then see what happens. Okay, but let me just finish this particular heap storage. Now, I don't know whether you guys know what heap storage is.
No.
I didn't either. And quite honestly, it's the definition of heap storage is a bit strange. It comes from, I think it comes from C++ or something. But what heap storage is on the IBM I is it's an area of storage that every job has or can have in memory. Heap storage, you can borrow a bit of it for your job at any time you need it. And it's managed in exactly the same way as user space. It is, in fact, a user space. However, the heap storage refers to dynamically allocated memory that a program can request and manage during runtime. Unlike static or automatic storage, which is allocated at compile time or during the execution of a procedure, heap storage is more flexible as the program can request memory as needed and free it up when it is no longer required. So you can grab a chunk of memory. Now, the advantage of this is that it is actually OS memory and runs at priority 0. So it is very, very fast. It operates exactly the same way as user spaces do, except it does not have dynamic sizing. And it's only available to a job within a job. You can't have it available to other jobs. You use the percentage alloc built-in function. And the number is how many bytes you want. That's all you have to do. And it returns a pointer to newly allocated heap storage of the length specified. So if you say percentage alloc 300, you will get a chunk of heap storage 300 bytes long. You are free to do with it as you like. If you find it's not enough, you can use the realloc. You put in the pointer that you got returned from here, and you give it a new number, and it changes the length of storage addressed by the pointer. It either makes it shorter or longer, depending on what you've asked it to do. And if you make it shorter, you lose what was in that space. If you make it longer, it's just empty space. And for some very strange reason, you have to use the dealloc opcode to free the allocation of heap storage addressed by the pointer. There's no percentage free function. It's the strangest thing I've ever come across, because I sought alloc, realloc, and I was looking for percentage free, and it wasn't there. Free is the allocation heap storage addressed by the pointer. You have to manage this. You have to free it up if you want to get rid of it. At the end of the job, it will be released, granted, but you take responsibility for it altogether. But it's much faster than even user spaces, but it's not dynamic. I've never used it. I don't use it because I find that user spaces are more than sufficient for my needs, and I really, really don't need to get involved in this sort of thing where I have to manage the space. And in this particular case, you can't find the pointer by using the name, because it doesn't have a name. So you would have to, if you wanted to pass this heap storage from one program to another, you would have to pass the pointer. You can't just look up the name and get the pointer from it. So I put it in there for completeness, but I wouldn't worry too much about your now. User indexes. Now, I'm not going to go into this in depth because I think you've had enough to scramble your brains for today. I'll use this to scramble your brains on Thursday. All right, so be prepared. This user indexes are another user-defined space, but they are to user spaces what data queues are to data areas, if you understand what I'm meaning. A data queue has different entries. A data area is one space. So user spaces are one space. User indexes have got multiple entries. They have major advantages in that they are auto-sequencing and all sorts of other things, but I won't go into that. I'm going to say to you, any questions that I can answer, because I'm not going into this now. It's too much for me and you. Any questions?
We do use data area quite a bit,
yeah,
and those are objects. They are very basic objects.
Data area, yeah.
Very easy to manipulate but if we want to replace that with something else like a user space or a pertinent or a permanent user space, then
yes,
we cannot do a list or a list of the content of those, and it's more powerful, but it's less easy.
Yeah, the data area is also flexible in terms of what you put into it. you have to put in a data structure and you lay down the fields. The problem with the data area, it's got a maximum of 1K, 1024 bytes. It's small. User spaces are much, much bigger. So yeah, I'm not saying you should take what you are doing now and change it all to user spaces. That I'm not saying. What I am saying, however, is that try and start working a little bit with user spaces, become familiar with it, because you will find they are so much easier to work with.
Yeah.
I just love them. I think they're the greatest thing since sliced bread. And that user indexes are the two very powerful tools that I find way ahead of the old style and old way of doing things. That's all. Because you get more flexibility, but more flexibility, you can also get more confusion, and you need to practice with them and try them out and debug them and see how they work. So I'm going to ask you to do that. I don't know how much time Bernard gives you to do this sort of thing, or is he slave driving you to produce for the system? I don't know.
Always.
Yes, yes.
Well, Tommy, it's that time of the year that we are just trying to empty the pipe, before New Year. So it's a pretty intense, and you know what? Not only us. I mean, users are calling us and pushing to get their things. So
we'll get this and that and the other thing. No, I understand. The end of the year is always terrible. I was the database administrator for a medical facilities company, and the worst part about it was that December the 16th, which is a public holiday in this country, was the deadline for medical plan changes. So as a company, all the changes came from the medical aids on December the 16th. And we had to have them done, completed, and finished by the 31st, because that was when the new plan started in the new year. So I understand what you're saying about the end of the year. It's a nightmare.
Yeah.
Anyway, do try to do something. We will go and look at indexes next session. And we can see how we go. There's only one more session before we shut down. And then Marinus and I are going to have to play games. So let us see how you go. And maybe in the beginning of the new year, you can get involved in these a little more. But I do advise you try. That's the only thing I can say. Because without doing it, it's never going to work. I want to actually, I've got these. What am I doing? Yeah, this is a statement that I stick it all over the place. And it's very true. When you first start making changes, it's hard. Once you get familiar with it, you don't know what the hell you're doing, and it gets very messy. But in the end, it's worth it. So I will leave you with that thought. How's that?
That's good. I mean, you're a true philosopher. How do you say that in English?
I don't speak French, so I can't help you.
Philosophic,
philosopher, yeah. Okay. Well, I try to, help people.
Yeah. Where's that? Cape Union.
That's Cape Town. That's the Table Mountain.
Okay.
Table Mountain in Cape Town. This is the waterfront, the Victoria and Albert waterfront, which is a huge shopping area and cafes and everything else. It's right in the harbor.
Neil, have you been there?
I don't think Neil got to Cape Town.
No, I didn't get there.
Okay.
But
looks like you missed something.
Well, I have a reason.
South Africa is actually a big country. It's surprisingly big. It doesn't look all that big in the Mercator projections that you see on an ordinary map. But if you take the actual size, you can actually put Russia into South Africa.
That's right.
Yeah. Russia is actually actual land area is about a little bit bigger than South Africa.
Okay. But what about Quebec? Quebec is pretty large as well.
But if you look, you get a map. You know, when you got a map with Africa in the middle, Africa is the right size. But as you spread out east and west, the expansion of what they call the Mercator projection is to expand because they're flattening a globe, so the land mass gets bigger.
Okay.
So if you take Quebec, there's the USA, Russia, the UK, and Canada all fit into Africa.
Yeah, Africa itself, it's very large. But what about South Africa?
South Africa is a big place.
Okay.
From the top northeast corner to Cape Town, which is bottom southwest, is 2,000. I think it's 2,400 kilometers across South Africa. Okay. So it's a big chunk of land. These are our pineapple fields. We grow pineapples.
Yeah, we don't in Quebec. We don't have that.
No, you wouldn't. It's too cold.
Especially not now.
No, not really. We've got the apple tree.
Oh dear.
All right. So thank you very much.
All right, it's a pleasure. I hope it didn't do too much damage.